Hello everyone and welcome to today's lecture of the ARD series, that is the Agriculture and Rural Development for the Nabard Grade A examination, which is relevant for both the phase 1 as well as the phase 2. So in fact not just the Nabard Grade A but also the Grade B, basically all examinations wherein the ARD syllabus which is asked in the Grade A exam is also asked. So that over there this chapter is going to be extremely crucial. So, as you might remember, in the very first chapter of the ARD series, we studied the introduction to agriculture, right? So, in the introduction, we actually saw that there are 7 major branches of agriculture, out of which the very first one was agronomy, right? The first was agronomy, and this agronomy is the branch which we are going to study in the chapter 2, which is going to begin now. So before we begin with this chapter, I would like to point out over here that before beginning you can actually go through the course notes which we provided, and you can at least get a brief idea and a brief gist of what agronomy is about and what all is going to be studied in this chapter. This will actually help you to get through the video in a much simpler and a easier manner, wherein you can save your time as well. Now you can also see the video and then go and study the notes, but I would highly recommend, if you want to save your time, if you want to leverage upon your time and optimize your preparations, then you can first go through the lecture notes in a brief manner, then you can actually see this video, and finally you can try to memorize the chapter or maybe make your own notes out of it if you want to. Okay, so it's totally up to you in that sense, but I would always say that please at least go through the chapter and see what is there. All right, so we'll begin with this chapter 2. Basically, agronomy is a branch of agriculture which deals with the field management, the management of field, management of crops, and basically how we can increase the productivity of our crops. Okay, so with that in mind, let's first see that what is the syllabus of Nabard Grade A, which is actually covered in this chapter. So the syllabus of ARD, which is covered over here in the actual notification, is agronomy, wherein the definition, meaning, scope of agronomy is supposed to be covered, and then the classification of field crops as well as the factors affecting the crop production. All of these are going to be covered within this chapter. All right, guys. So let's move ahead and begin with the introductory slide, wherein we'll first try to understand what is the basic meaning of agronomy, what agronomy is all about, and an introduction to agronomy in general. So agronomy is basically a word which is derived from the Greek words number 1 agros and number 2 nomos. Okay, so agros means field and nomos means management. That is why you can just memorize these two words and you would actually get a gist of the entire chapter, wherein agronomy is a science or a branch of agriculture which deals with field management. All right, the central theme of agronomy is soil, crop, and environment relationship. So there is a relationship between these three factors: soil, crops, and environments. So whenever you sow a crop in a field, the soil will be a limiting factor which will affect the productivity of that crop in a varied number of senses. So if the proper nutrients are available, if the soil is tilled properly, if the soil is aerated properly through plowing or tilling, if the soil has a lot of microorganisms in it, if the soil has a good amount of manure, if the soil is perfect in the macronutrients as well as the micronutrients. I hope you know that there are three macronutrients, which is N, P, and K: nitrogen, phosphorus, and potassium. And then there are a lot of micronutrients as well, which are supposed to be covered later on in the chapter of soil. But just to give you a sense of it, the all of these nutrients and all of these factors of soil definitely definitely have an effect on how the crop production is varying. And similarly, apart from this soil, the environment is also very crucial towards the crop. For example, a crop which is grown in the summer season cannot be grown in the winters. Similarly, a crop, for example, rice, which is highly uh, intensive in terms of water or irrigation, it cannot be grown in a dry environment, or let's say in the Thar desert, right? So the environment is also very crucial towards the crops and how the productivity of the crops varies. So the central theme of agronomy is the soil, crop, as well as environment, all of these three things, how their relationships vary. Okay. Next, there is a fact that the father of agronomy is Pietro de Crescenzi. Okay, I don't know how you want to pronounce it, or how do you want to say this word, because again it's not a standard English word. So, but whatever matters is that you should know these spellings, because ultimately that is what's going to matter in the examination. So Pietro de Crescenzi is the father of agronomy. Then there are four dimensions of agronomy. The first dimension is physical, then is biological, then economic, and final social. Okay, so these four dimensions of agronomy are actually crucial towards how the field management is done and how the productivity of the crops varies. So the physical dimensions are the ones which include, let's say, soil, water, then nutrients, and even sunlight. All of these are basically the physical factors. Then come the biological factors. Biological factors are the ones like the vegetation around the crop. Is there a forest nearby? Is the field actually surrounded by trees which act as maybe a windbreaker or something? So the vegetation, the crops, the trees, then what kind of animals are there, that is also very very crucial, because again I hope you might understand this, that animals are also bearers of uh, the crops seeds. In many cases that becomes important, and then in a lot of cases animals are actually deterrent towards the crops because they come and destroy them. So that is again a very important factor, and even more than that, then insects come into being, and insects is again a very crucial factor, because insects help in pollination. Insects help in the formation of seeds from the flowers, seeds or fruits from the flowers, because no pollination, especially in terms of the plants which need the pollen to go from the stamen to maybe the other female part, that over there it becomes very very crucial, like how many insects are present in the field, is it sufficient, is it actually. So all of these factors come under the biological ones, and they are also very very crucial. Then come the economic factors. Economic is the ones wherein the farm structure. So economic is basically the money factor, and the money factor will actually affect the size of the farm, the structure of the farm, as in if you can use, let's say, mechanized farming wherein you can use tractors and all, or if you are still relying on the primitive kind of methods. So all of those come under the social ones, and sorry, the economic ones. And then there's the social factors as well. So in the social factors there is things like food, nutrition, health, all of these come into being. So according to that, the kind of crop that you are growing will change, the kind of output and productivity you want will change, how you market the crop, everything changes with the social aspects as well. So these are the four basic dimensions according to which agronomy is having. Okay. Okay, so crops are basically the plants which are cultivated and grown commercially on a large scale. Okay, so you can have many kinds of plants, but if a plant is cultivated and grown commercially, and just a second, yeah, commercially, and that too on a large scale, then that kind of a plant is known as a crop. Okay, so that's the definition of a crop. So there are three aspects to it. It's a plant, it's grown commercially, and on a large scale. Okay, so crops are basically grouped into three main classes, and uh, this classification is basically done on the scale of cultivation. Okay, so on what kind of a scale, how large is the scale of cultivation, on that basis there are three major classes that are crops are broken down into. So the first class is garden crops. Garden crops are basically the ones which are grown on a very small scale, basically at the back of your house, or in your garden, that's where they are grown. And the purpose of growing garden crops is also either personal consumption or a very very small scale. Okay, so in the kitchen you use it, or in your household. Then comes the second kind of crops, which is field crops. Now field crops are the ones which are grown on the most extensive scale. All right, so on a very large scale is what they are grown, or in fact instead of large you can say vast scale. Okay, so they are grown on a very vast scale, and these crops are basically grown seasonally. Okay, so crops like rice, wheat, sugarcane, all of these, pulses as well, all of them, they come under this field crops. Then comes the third category, which is of plantation crops. Now this lies in between the field and garden in terms of the size. So it's a large scale but not as large or as vast as the field crops. Okay, so it's a large scale, but these crops are not seasonal. Why? Because they have a lifespan of at least 2 or more than 2 years. So these crops are basically known as perennial crops. Okay, so what are these crops known as? Perennial crops. And perennial crops, for example, you can say tea, coffee, and then rubber. So all of these crops are basically grown on a large scale in plantations. Okay, so plant by plantations I mean they are estates. So I hope you must have seen tea gardens, or coffee estates. If not coffee estates, tea gardens are very common, and most people have seen them. If not in real life, then at least in photographs. So tea gardens are basically estates. Okay, so a plantation is basically a crop which is grown on an estate on a large scale but not a vast scale, and the crops are perennial, which means they have a lifespan of 2 years or more than 2 years. I'm sorry, not 2 years, but definitely more than 2 years, because 2 years comes for the biennial crops. Okay, so perennial crops more than 2 years, at least. I mean, 3 years, 4 years, 5 years. That's the lifespan of these crops. For example, if you grow a tea crop, then you'll have to plant the bush once, but it will keep giving you the tea leaves for at least a few years. So that's how it functions. So that's the plantation crops. So these are the three types of crops. Now moving ahead, the types of field crops. So there are certain types in which the field crops are divided. So there are cereals, for example your millets, your wheat, barley, paddy, all of these come under cereals. Even rice and I'm sorry, rice, wheat, and your maize, all of them come under cereals. Then pulses are the grain legumes which are used as food. So they are basically high protein rich legumes, and pulses are again a very crucial aspect of our diet. And the examples of pulses, you can take grams, beans, peas, all of these come under pulses. So that is the second categorization. Then there are oil seeds. These are basically grown for their oil. So oil is extracted out of these seeds. For example, you can say sunflower is there, then groundnut is there, then castor seeds, soybean, all of these come under oil seeds. Then there are the sugar crops. Sugar crops are basically the ones from which sugar, or processed sugar, is actually extracted. That is the main purpose of growing these crops. So there are two crops which come under the sugar crops. The first is the a crop which everyone knows about, which is sugarcane. And then there is another crop which you generally tend to forget, which is sugar beet. So always remember that sugar beet is also a crop which can be used for the production of processed sugar. So both of these come under sugar crops. Then there are the fiber crops which are used to make fiber which is made into cloth, and then your clothes and all of those things are made out of those fibers. So fiber crops like cotton and jute, and then mista, all of these come under the fiber crops. Okay, so these can also be used to make ropes, they can be used to make gunny bags and all of these. So fiber crops are again a different category. Then come the commercial crops. So commercial crops are basically the ones which are grown for the purpose of profit. Okay, so by profit I mean that at least 75% or basically greater than 75% of this crop is actually sold in the market. Okay, so if you have a field in which 100 units of a crop is grown, out of that if 80 units are actually sold in the market, then this field is of a commercial crop. All right, so that's what commercial crops are all about. Then come forage crops. So forage crops are basically the crops which are grown for feeding to animals. So crops like, let's say, your hay and all, any kind of crop which let's say you're growing napier grass or something. Napier grass is again a very important grass which was asked in the Nabard exam last year as well. It is also known as elephant grass. So if you're growing a crop like, let's say, napier grass, then they come under forage crops. So the next is green manure crops. Green manure crops are again the crops which are used to improve the soil productivity. And how are they used to improve the soil productivity? Because once they're grown, they're actually incorporated in the plant tissue in the soil, as the plant tissue in the soil itself. So let's say if you are growing sun hemp, then what you do is that you grow sun hemp and then you do not cut the crop. You actually uh, take this, you make the crop tissue get uh, incorporated into the soil itself. So let's say if there's this field wherein sun hemp has been grown, then what you do is you will ultimately make this crop get broken down in the field itself, and in the field only it will be incorporated in the soil. And once it does incorporate, then it will break down into the nutrient format, and then this soil will become rich in terms of those nutrients, and ultimately it can be used for growing, let's say, wheat or maybe any other crop which you want to grow in the next season. Okay, so these are the green manure crops. Then come the spices and condiments. Spices and condiments are basically used for providing color, flavor, or aroma to food. Okay, so these are not directly used for the nutritional aspect of it, but they are used because they get paired well with the foods. So your spices like coriander, and then condiments like ginger, garlic, turmeric, all of these come under the spices and condiments. Okay, so next is the classification of field crops. Now field crops are classified into various types based on what kind of classification you're doing. For example, if you're trying to classify the crops on the basis of climate, then you can say there are tropical crops like mango, sugarcane, maize, coffee, banana. All of these are tropical crops. Then you can say there are subtropical crops like citrus, pomegranate, fig, date. All of these are subtropical crops. And then there's temperate crops like wheat, oats, apple, strawberry, grapes. All of these are temperate crops. So if you're doing it on the basis of climate, that's the kind of classification which you can do: tropical, subtropical, and temperate. Okay, but then there's another classification which you can do, which is on the basis of seasons. Now on the basis of seasons, and mind it, this is a very important classification because this tends to be asked in the exam a lot of times. So seasonal classification is basically in three terms, which is kharif, rabi, and zaid. So what are these three crops? Kharif are basically the crops which are sown in June or July, and they're harvested in September, October. Now the examples of these crops are rice, maize, groundnut, jowar, bajra. And then any, especially these are the core crops which you always need to remember. Do not forget any single name out of these for all of these three crops, for all of these three types of crops. And apart from that, you can also go ahead and try to find out which all crops are kharif, rabi, and zaid. You just it's very easy to find the list, and if you want you can actually go through the entire list, but again the list is very it's very huge. It's a very big list. It might not be easy for you to remember all the names, so I've at least given you the key names over here, which are like the basic crops which can be asked in the exam. So the first is kharif, the second is rabi, and the third is zaid. Rabi is grown in the winter months, which is October, November, and then it's harvested in March and April. And zaid is the the months between Kharif and Rabi. So Feb and March is when it is sown and it's harvested in the summers in May and June. Okay, so Kharif crops are basically the ones which utilize the monsoon. The Rabi crops are basically the ones which are grown in the winters. So from winters, you can easily remember that which crops are grown in winters. First of all, wheat is the most important crop. Then there's mustard, barley, cauliflower, cabbage, and potato. Potato is again a very important crop over here. So these are grown in the winters. And then there's the zaid, the third kind of crops, which are gram, cowpea, sesame, cucumber, watermelon. So basically, cucumber, watermelon, all of these come under cucurbits, and garden all also come under cucurbits. So cucurbits are grown in the Zaid season, and then there is gram, cowpea and all, and sesame as well. So all of these are also grown in Zaid. So Kharif, Rabi and Zaid, it's very important, guys. Remember the months, and even more than that, remember these examples by heart. Okay, remember these examples by heart. Then come the classification of field crops. Third part is life cycle of the crop. So life cycle is basically the it's also known as the ontogeny, and for example, wheat, rice and peas and watermelon, all of these are actually a single season crop, right? So you grow it in let's say, if you're talking about wheat, I'll correlate this with the previous one. So wheat is basically a rabi crop, and you sow it in October, November, and then you harvest in March or April. So it's roughly a 4 to 5 months game, right? So 4 to 5 months is basically nothing but a season. So any kind of crop which is grown for a season is known as an annual crop. And then there are crops which are grown for 2 seasons or 2 years. So basically you grow it once and it reaps in 2 seasons. So this is a biennial crop. And then there are perennial crops which are grown for 3 or more seasons. What we were talking about before when we saw the 3 types of crop classifications, right, over here. So these plantation crops, right, they were known as perennial crops. So that is what we are studying now. So perennial crops are the ones which are grown for 3 or more years, basically more than 2 years. So tea, mango, rubber, sugarcane, all of these come under perennial crops. Then there is on the basis of mechanism of photosynthesis, and over here there is the C3 plants which utilize the Calvin cycle, and then there are the C4 plants which use the Hatzlack cycle, and then there are the CAM plants which are the crustacean acid metabolism ones. So these are basically explained in detail in a table that I provided you in the content, and over there you can go through the entire table. It's very easy to understand. You can try and understand the C3, C4 and CAM mechanisms, but I haven't discussed it in the presentation because they have these mechanisms have never been asked in the exam before, and it's highly unlikely to be asked. So you can definitely, it's better that you don't leave this out of the syllabus, but if you're really short on time, then you can leave it out, because uh, 90% chances are there that this question will not be asked in the exam. But still, if you want, you can, I provided you an entire detail of C3, C4 and CAM. You can study it over there. It's very simple. Okay, so this is on the basis of the mechanisms of photosynthesis, how the plants are utilizing the sunlight to complete their photosynthesis cycle. Okay, then there is the root system. So there are tap roots, which is a big tap kind of thing is there, and then fibers come out of this tap root, the main root basically. And then there's the fibrous root system, wherein a plant can have multiple fibers coming out of the base, and over there above this is the plant. Okay, so then there is also another kind of a classification, which is shallow roots and intermediate and deep roots. So shallow roots are less than 1 meter, intermediate roots are 1 to 1.5 meters, and beyond that are deep roots. So again, this is a classification which you can remember, but there's not much that can actually be asked in the exam from this. Okay, moving ahead, classification of field crops. Sixth part is economic importance. So economic importance is again an interesting factor according to which crops are classified. So there are crops like cereals, pulses, legumes, oilseeds. The classification which I gave you before, this can be done on the basis of economic importance. Then there is on the basis of botanical or morphological similarities. For example, angiosperms. Angiosperms are basically the flowering plants with enclosed seeds. Then there are the gymnosperms, which are the non-flowering plants with naked seeds. Okay, which are not enclosed. Then there are the monocotyledons, which have a single or one cotyledon. For example, rice, wheat, maize, sugarcane. You can remember the names of these plants which are monocotyledonous. Might be asked. Not highly likely. Hasn't been asked till date, but you can still remember. It's easy. Then there's the dicotyledons, which have two cotyledons in them. For example, mango, sugarcane. Mango, sugarcane is monocotyledonous. Mango, sunflower, legumes, and neem. Now, mango and most other plants in this list, except for legumes. Legumes are still easy because you can actually see the legumes having two cotyledons, but mango, sunflower, and neem somehow becomes tricky for students. So you actually have to remember that these are not monocotyledonous; they are dicotyledons. Then there are other crop terminologies which are also given towards the end of the first part content which I provided you, and there are a lot of terminologies. The entire list is not, the entire list is pretty much exhaustive for your examination, and you need to definitely cover all of them. You should know what, for example, what alley crops are, what forage crops are, what all of those crop terminologies, you need to remember them. So just again, there's nothing much to explain in those, so just go through the list, and it's easy to remember. You will be able to understand that. Okay, so now we'll move to the next topic over here, which is soil preparation and tillage. So first of all, let's talk about soil preparation. So what happens is that when you have to plant any crop in the soil, you have to prepare the soil before planting that crop. Okay, so before sowing any crop, the preparation is very important. Now this soil preparation consists of three different uh, steps which can be followed. The first one is plowing. Okay, the first one is plowing. The second is leveling and manuring. Leveling and manuring. And then the third one is, I'm sorry, the third one is manuring. Okay, so basically these the soil preparation techniques are the ones which we use before we start the sowing. Okay, so plowing is basically nothing but breaking up of the soil by means of a plow. You must have seen a lot of farmers plowing the fields with their bullocks or maybe with the tractors. So plowing is nothing but the breaking up of the soil, and apart from that, leveling is very simple. It's basically, you level the field so that there is it's leveled so that the irrigation water does not go towards one side or maybe get logged, or you try to ensure that the leveling is equal in the field, or maybe it's according to how you want the water to go when the irrigation is done. Then manuring is something that we'll discuss later when we are talking about fertilizers, so you don't need to think about it right now. Right now, plowing is the important aspect for your exam, which we will be covering. And then there are two very similar terms, plowing and tillage. Okay, so we will be discussing both of these terms. The first is plowing, and the second is tillage. So what is the difference between, so these terms are actually used interchangeably in a you know at times, at a lot of times actually. So what is actually the difference between tillage and plowing? Tillage is basically, if I try to make you understand in terms of a Venn diagram, it will be simpler. So if this is tillage, then this is plowing. Okay, so plowing is basically a subset of tillage, and tillage is a very broad term which which is actually used to prepare and cultivate your rakes in the field. So basically, whenever you have to sow a crop, you have to prepare the in the field, you have to prepare the rakes, and you have to actually plant the crop in those rakes, or maybe have to somehow level the land, maybe reduce the lumps of soil or aerate the soil or anything. For that, you till the soil. So tilling is a broader term. It can be done in the primary sense of it, or the secondary tillage is also there. There are multiple aspects towards tilling, and then plowing is a very small subset of tilling. Okay. Now the detailed definitions are something which of course you can go through in the notes. But what I'll try to make you understand over here is that why we do tillage. So tillage is basically done to ensure adequate aeration in the soil for gaseous exchange. Okay, because the seed and the root zone require exchange of gases, and that is done through the proper aeration of soil. For that, tillage is very important. Then adequate seed soil contact to permit water flow is also another objective. Then non-crusted soil to permit seedling emergence, low density soil that permits root elongation and proliferation, to create an environment that provides adequate light to the seedling before it's germinated, to create pest and pathogen free environment, to mix the applied manures and fertilizers, and to remove the hard pan of the soil, and if any, to increase the soil depth for water absorption. So all of these are the objectives of tillage. Of course, you should remember them, because there have been multiple choice questions which have been asked, like which of the following is an objective of tillage, which of the following is not. Especially, soil aeration and the removal of the hard pan and non-crusted soil. These are very important. You should know. Of course, the water flow is also important. So you should know all of these points. Moving ahead, the types of tillage. Now the types of tillage is again very important. You need to understand what kind of tillage are done. So there are preparatory cultivations, and then there are the after cultivations. So in preparatory cultivation, there's primary tillage, and then there's the secondary tillage. Primary tillage is basically the one which is done before sowing. Okay. In fact, why even write this? So there is sowing, and then sowing is always, so if this is the timeline over here, it is sowing, then sowing is always preceded by the primary tillage, okay, or the PT, and then post sowing is what you do, secondary tillage or the ST. Okay, so the secondary tillage is basically done after the crop has already been sown in the field. So primary tillage is again of three types, which is deep tillage, subsoiling, and year-round tillage. So the deep tillage is basically the one which turns the large sized chunks or large sized clods of soil into smaller chunks, or basically breaks down the soil. That is the core aspect why the deep tillage is done. Then there's subsoiling. Subsoiling is basically done to remove the hard pans of soil. So basically, let's say this is your entire soil profile, wherein this is your topsoil, this is your subsoil. So if the subsoil is extremely hard, if there is a hard pan of subsoil over here, then what happens is that this hard pan of subsoil will not let water go down, so water will start clogging in the fields, and then there are other problems which start getting associated with it. For example, there can be the salinity of soil and all of those. So if you want to break this down, then what will happen is that you will actually have to, when you're plowing the field, you will have to penetrate deep enough to reach this, or I'll show it in a different color. So you'll have to penetrate the soil to reach this layer, and then you'll have to take this plow and actually go in this direction and break this entire hard pan of soil. Okay, so to do this, you have to go deeper into the soil, and that is when a different category of primary tillage comes into being, which is the subsoiling. Then there is the year-round tillage, which is basically the tillage operations that are carried out throughout the year. So for example, in dry farming regions, the farmers basically have to do repeated tillage operations until the sowing of the crop. So this comes under a year round tillage. Okay, it's very simple. It's basically comes from the word itself. Year round means done throughout the year. So then there are secondary tillage. Secondary tillage is basically done after sowing of the crop. So for example, harrows and cultivators are used. So let's say you've sown a crop in this field in these rakes, and then what happens is that after sowing, weeds have started growing over here, or maybe unwanted plants are growing. So what you do is you have to do a secondary tillage to remove these, so that the these these crops which you've grown, they have optimum nutrition and there is less competition for them, so that you can have an optimum crop. Okay, so to remove these unwanted crops, secondary tillage is done later on. Fine. Then we move towards the layout of the seedbed. So after the seedbed preparation, the field is basically laid out properly for irrigation, sowing, and planting the seedlings, and that is basically what comes under the layout of the seedbed. Okay, again a very simple thing, you can go through the notes, it's very easy to understand and not much to actually tell in the laying out of the seedbed. Then there is the after cultivation. Now before the cultivation, you've understood, you have to first do the primary tillage, then you have to sow the seed, then you have to do secondary tillage, then you finally do other operations, and you end up reaping the crop. But what happens after cultivating? So after you cultivate the crop, there are other tillage operations which are supposed to be carried on, and they come under the after tillage. For example, you use blade harrows and you use rotary hose in case of the in case of controlling the weed between the crop rows and intercultivation and all of those things. So, let's say you've grown one crop over here, but then you want to grow another crop maybe a couple of months afterwards. Again, after cultivation will be what you use now. So again, different kinds of operations which come into this, and all of these will definitely be covered later on. So classifications of tillage. Now tillage can actually be classified in various senses. For example, if you try to classify on the basis of seasons, then you can say that there is off season and on season tillage. Basically, on season is the one which is done during the season, and off season is the one which is done after the season. For example, post harvest, which is done after the harvest is completed, or maybe fallow tillage, when you have left the soil or the field fallow for at least a season or so, then you do fallow tillage. Then there is the summer and the winter tillage. So all of these come under the off season ones. Then there is the modernization based tillage, which is conventional and conservation. So conventional tillage is the standard one which we've been practicing till date, and then there is conservation tillage, which comes with a totally different kind of a philosophy over here, which says that if you are doing tillage, then you are actually you're disturbing the field and you're disturbing the soil. And when you disturb the soil, in this soil layer, there are good microorganisms as well. Okay, and then there are, apart from these good microorganisms, there is also earthworms over here, and a lot of other things which are important for the soil and important for the crops as well. Now what happens is, when you do tillage, as soon as you do this tillage in this field, these earthworms and microorganisms, they will be moved and displaced, and most of them will actually die with the tillage operations. So again, this is not an ideal kind of a operation. So this new kind of a modernized mindset says that conservation tillage is a much better approach towards how you can cultivate crops in your field. So there's minimum tillage, which says that we have to reduce tillage to the minimum and try to do all kinds of operations in a single tillage. For example, let's say you are first doing the primary tillage, then you are sowing the crop in a different you know uh, in a different operation, again using your tractor and machineries. Then you're doing the secondary tillage again, and then 3 to 4 kinds of tillages are done in a span of maybe 60 days or so. Instead of that, what you do is you do all of these operations in a single pass of the till. So in the same operation, you plow the field, and then at the same time, along with plowing, you're also sowing the seeds, and also at the same time you're doing some operations which will reduce the unwanted plants in the field. So the weeds and all, they will be removed. So if all of that can be done in a single pass, then there will be less disturbance of the soil, and at the same time your soil will remain much more healthier. So that is what minimum tillage is all about. Then there is no or zero tillage, in which tillage is not done at all. And then there is the stubble mulch. The stubble mulch tillage is again very interesting, and in fact I guess questions have also been asked in the Nabard exam previously from the stubble mulch. So stubble mulch is basically when the soil layer is kept protected by the crop which was grown previously. So what happens is that you grew a crop over here in a field, and then what happened is that you harvested this crop. After this, the crop residues are still there. For example, uh, you took the let's say you talk about maize. So in maize, what you do is you remove the maize from the entire plant, and then the corn is basically removed from the entire plant, and then the remaining maize plant is basically nothing but a waste. Okay, so this waste, what you do now is you do not actually go ahead and do another tillage operation to remove it. You let it lie fallow in the field. So what this will do is, this will first of all prevent any kind of soil erosion in the field. Secondly, it will also keep the field more, let's say, more moisture in the field, and then once it dries down, it will ultimately disintegrate in the field and provide more manure and nutrients in the same way as green manure is used. So in that sense, a stubble mulch is a very different kind of an approach, and it's very innovative and very good. So it keeps the moisture over there. Mulch is basically nothing but any kind of a crop or any kind of an organic material, or even plastic sheets are also used these days as mulch. So mulch is something that can just keep the soil moisture for the plants. Basically it can keep the soil covered and there is no erosion, and also the moisture is remaining in the soil. So stubble mulch is basically when stubble is being used as a mulch. All right. Then there are the special operations wherein subsoiling, clean, blind, dry, puddling, all of these sub operations are done. So basically subsoiling is nothing but the non-inversion tillage, wherein you're going deeper into the soil, at least 14 inches or deeper, wherein you're trying to remove the hard pans from the subsoil. Then there is the clean tillage, which basically refers to uh, the practice wherein no living plant is left undisturbed in the till in the field. So basically what you do is you try to clean all of the vegetation in the field by doing tillage. So every single plant that was there should be removed or disturbed in such a manner that they die. So it's kind of an unweeding kind of a process. So it is a clean tillage. Then there is a blind tillage. Blind tillage is basically a kind of clean tillage but in a different manner, because this is done after sowing of the field. So clean tillage is done when you're trying to clean the field, but blind tillage is done when the field has been sown. So you've sown the seeds into the field, but now every other plant which is growing in the field, you want to remove that. Then you do the blind tillage, because in this kind of tillage it's different from clean, because now you have to ensure that the seeds which have been sown, they do not get displaced. Okay. Then there is dry tillage, wherein the field is dry. Dry means it's not devoid of moisture. It's not like that there's no moisture. There's basically 20 to 23% moisture which is ideally present in the soil when this dry kind of tillage is done. And then there is puddling or wet tillage, which is again very important. Puddling has also been asked in the exam before. So puddling is basically a kind of an operation which is mostly associated with paddy or rice. So what is done is that the entire soil is covered with water, and then it is tilled again and again and again to reduce the air gaps in the soil, so that this water which is being filled in the field, it does not seep down to the lower layers of the soil, and it stays over there, because the entire paddy crop needs to be submerged in water for it to grow properly. Okay, so then puddling operation, again it's very important. Then tillage implements. So the primary tillage implements are, first of all, is the wooden or indigenous plow. So again, I hope you remember that primary tillage is the one which is done before sowing. So the implements which are used for this primary tillage, the first one is wooden or indigenous plow, which I hope you must have seen. It's a very standard kind of a plow which is tied before the animals. It's also used with tractors these days. So it's a standard plow which displaces the soil. It kind of goes inside the soil, and then the soil is displaced and the soil is also turned upside down with it. It's very very simple kind of a process. Then there is the proper soil turning plow. Now in this, the soil is only displaced, but this soil turning plow actually is designed in such a manner that this will ensure that it goes deep inside the soil, and then as this pass is done, the soil will totally turn upside down. So the lower layer of the soil will come up and the upper layer will get inverted, so that any kind of weed which was growing over there will die, and then lower nutrients will come up. Okay, so that's the soil turning plow. Then there is the mold board or the MB plow. It's again a very very common name, MB plow. Some students get confused in what this MB means. MB is nothing but a mold board plow. So if you talk about the top view of this plow, it will look something like this. So if this is this lever, this cantilever, then this is how the plow direction is. Okay, so it's not in a straight direction, these are in a tilted direction, and now this is the direction in which this pass will be done. So they will be like this in this direction when this mold board plow goes ahead. Okay, so this is a mold board plow. Again, mold board plow actually helps in inverting the soil, and it's a kind of a soil turning plow. Okay, then comes the disc plow. Again, this disc plow, some students think that these discs will move straight in the field, as in if this is the disc, then some students think that in a disc plow, these discs will go like this in the field, but that is not the case. Because if you're talking about this, you must have seen this kind of an operation as well in the fields. But if the disc is going straight, if it is rolling straight in like a wheel, then it's not a disc plow, it's actually a disc harrow. Okay, then what is the difference between a disc harrow and a disc plow? A disc plow is basically moving not in this direction but in this direction. So the I mean, not exactly this, but it's slightly tilted. So you can say that the wheels would be tilted like this, just like the MB plow. They are also tilted like this, and then they move in this direction. So, and the last wheel is straight. Again, there are multiple variations of this which you can see, but then when this plow will actually be moved forward, these wheels will churn the soil, and this soil will churn and get overturned. Okay, so the lower layer will come up and the upper layer will get inverted. So that is how the tillage is done. If these wheels were taken straight, then this would have not churned the soil, and then this would have not been a primary tillage operation. All right, so that's a disc plow. Then comes the turn rest or the reversible plow. So now the reversible plow, now as you can see that I told you that this is the direction of a mold board plow. What if you want to till in this direction, right? If you want to till like this, then you'll have to take the tractor and take a U-turn and come back, right? But what if now you're in a terrain which is not easy to uh, you know maneuver the tractor? Let's say you're in the hills, you're in a hilly terrain, and in that case you do not have the space is not enough to move the tractor like this. And even if the space is enough, it's not a kind of an efficient mechanism, because you're burning fuel and you're burning energy and time as well when you're trying to turn the tractor in a U-turn kind of a fashion just to change the direction of the plow. That is when the reversible plow comes into being. And the reversible plow, it's nothing but there is uh, the standard mold board plow, wherein the mold boards are in this direction, but then another mold boards another set of mold boards are attached towards the upper side of it, which are in the opposite direction. So the lower mold boards are in this direction, then the upper mold boards are in the opposite direction. And if you want to change the direction of the mold boards, all you need to do is just rotate this cantilever. As soon as this cantilever is rotated, the direction of the mold board changes. So that is when the turn rest or the reversible plow comes into the picture. Then there is the subsoiler. Now you can see the subsoiler is going deeper into the soil, and then after going deeper, that is where the broader portion of the plow starts, because it needs to actually have an effect on the subsoil and not the upper layer of the soil. So it tries to keep the upper layer uh, undisturbed or disturb it as minimum as possible. Okay. Then with this subsoiler, there is also another variation which is known as a chisel plow, very similar to this. Then there is the so there is the chisel plow. In chisel plow, again, you're going deeper into the soil, but you can see that the number increases, the number of these plows increases, and then the shape also changes. Fine. Then there is a ridge plow. The ridge plow, again, very simple, comes by the name. There is a ridge in the center, and then there are flaps on both sides. So basically, this will uh, turn the it will turn the soil or the mud in both the directions, and from the center it will get displaced. All right, so that's the ridge plow. Then there is the rotary plow, and again you can see from these blades in between that what these blades will do is they will actually, when they rotate, they will churn the entire soil, and they will kind of displace it, and at the same time break up all the lumps of soil which are present. Okay, so that's the rotary plow. And then there is the basin lister. So a basin lister is basically a kind of a plowing method which is used in conservatory tillage. So we're trying to conserve the soil over here, and you can see that there are bunds and checks which are created like this. So what you do is you start plowing from here, and then by the time when you're going in this direction, it's taking some amount of soil with it, and it is leveling the field, right? And then it is also breaking the lumps of soil. Now once you reach this point, what you do is you slightly raise the plow, and then you put it down again. And when this operation is done, all of the soil which was brought with the plow, it will make a check over here. So these checks or bunds are created, and that is how a basin lister works. So it's basically a conservation kind of tillage, wherein you're trying to create checks for the water, so that the water does not flow throughout the field, and the soil does not get eroded with it. Okay, so these are the primary tillage implements. Then there comes the secondary tillage. In secondary tillage, there is cultivator, and then there is the sweep cultivator. So a cultivator is, so first of all, I hope you remember that in secondary tillage, we are basically doing this tillage after sowing of the crop. So now we do not want to uh, displace this sown crop. We basically have to ensure that this crop is not uh, in any case maybe removed with the weed, or there is no problem with the growth of this crop. So what you want to do is you want to only remove the weed aspect. Now to do that, you can use a cultivator which is actually leaving out plants in rows, and in the intermittent areas between the rows, it is actually removing any kind of plant which is there, any kind of weed or any kind of unwanted plant which is there. So again, cultivators can have round wheels which can be seen in this picture, or instead of the wheels they can also have straight spikes. Okay, there are multiple variations of these cultivators. Then there's the sweep cultivator. Now as the name suggests, it has a sweep kind of a structure towards it. Okay, so this is a sweep cultivator. Then there is a harrow. Harrow is basically having these spikes. And then there is the disc harrow. Now the disc harrow, instead of these spikes, it has discs over here, and then these discs can be in this kind of a shape, or they can also be in a totally round shape. This shape can be seen over here, and then this is not the only shape which is possible. Totally round discs are also possible. But I hope you remember that if it was going in this direction, then it was supposed to be a plow. But now, because these wheels are going in the straight direction, then it becomes a harrow, because now in between the sown crop can be left undisturbed, and over here the weed or unwanted plants can be removed with this harrow. Okay, so that is the disc harrow and the standard harrow. Then we move ahead, the blade harrow. Now blade harrow is basically an entire blade which is there are two or three levers over here, and then these levers support an entire blade. So this is basically used to kind of level the field, or kind of do the weeding aspect when the crop has still not been germinated. Okay, and then this blade harrow has another kind of a version which is known as a guntaka, or basically the indigenous harrow. So these indigenous harrows basically have only two levers. This lever is not there, so they have only two levers, and these two levers support the entire blade. All right. Then there is the plank and roller system. Planks are basically, you must have seen people doing it in the fields if you come from an agricultural background, or if not, then you must have seen somewhere, maybe in movies or in videos or somewhere, that like there are two bullocks, and then behind them a plank is tied, and then sometimes even the farmer is standing on this plank, and then this entire plank goes through the field and levels it up. So this is again a secondary tillage kind of an operation which is done with a plank. And many a times, instead of a plank, there is also a roller. This roller is a very standard kind of a thing which is used even in gardens, and even in the development of, let's say, hockey fields, cricket fields, pitches. So over there also rollers are used. So roller is also a secondary tillage kind of an implement. Then there is hoe and star weeder. These are basically handheld instruments. So hoe is again a very common instrument which is shaped something like this, and it is used a lot in gardening and farming activities wherein manual labor is used. So this kind of an implement is used, and the process is known as hoeing. And in this hoeing, what is done is that any kind of extra weed is removed, and then with the plant, let's say this is the plant. So what is done is that over here a mound of soil is created, and this mound is created so that some extra nutrients can be available for the plant, and the plant is also supported by this. Okay, so this operation of creating a mound of soil around the plant, and at the same time removing any kind of additional weed with a hoe, is known as hoeing. Okay, then there is a star weeder which is again used manually. So it looks something like this, and then each of them has a, yeah. So you must have seen this also in even in English farms. This is used. So you must, not just India, but in farms abroad as well, this is used. So this kind of an implement, it has a star kind of arms in front of it, and then this is used to remove all of the weed in the field. Okay, so this is a star weeder. Okay, so moving ahead, we now have the factors affecting crop growth. So there are various factors which are very important towards the growth of a plant, and basically they limit the growth in many cases as well. So what all are these factors which affect the crop growth? There are broadly of two types. So the first one is internal factors, and the second is external factors or environmental factors. The internal factors are basically genetic or hereditary, and they depend upon the type of crop or the type of seed which you've chosen. And the external factors are basically climatic, edaphic, biotic, physiographic, and socioeconomic. Okay, climatic is again something which we already discussed before. Edaphic is basically uh, just a second. Yeah, So climatic factors is something which we've already discussed before. It is very very simple. It depends on the climate. Then there is the edaphic factors, then biotic factors, physiographic factors, and socioeconomic factors. Okay, so all of these factors are playing a very very crucial role in the growth of a plant, and they've all been discussed in detail with the notes, and you can of course go through them. So I was talking about the edaphic factors, right? So the edaphic factors are basically the factors which are related to the soil. Then there are the biotic factors which are related to, you know, all the biotic components like the animals, the plants, and the insects, all of those things. So those are the biotic factors. Then there are the physiographic factors and the socioeconomic factors. Okay, so all of these are actually the factors which affect the crop growth. It's very easy, nothing to remember in this, nothing direct, nothing rocket science which can be asked in the exam. Very very simple terms which you need to understand. So over here there is only I guess biotic is again simple, climatic is very very simple, physiographic is a simple term, sociographic is simple, edaphic is a term which you might not have heard before. So edaphic is anything which is pertinent to soil, for example the soil pH, or the soil moisture, or any of these things which is related to the soil, or even the soil nutrient level. All of those are edaphic factors. Okay, so moving ahead, the factors which affect the crop growth. So now all of these factors are theoretical, they've been discussed in the theory, but there is one aspect which I wanted to discuss separately with you with these factors, which is the optimum temperatures and the optimum rainfall. Okay, number one the temperature, and number two the rainfall. Now there is a table over here. I've, you know, showcased only the top 10 crops in that table, but there's a table containing almost 25 to 30 crops. To be exact, there are 27 crops in the table, and they've been given towards the end of this chapter of agronomy. Now don't ignore the table, it is extremely crucial for the examination, because both the optimum temperatures and the optimum rainfall amount for the crop, they can directly be asked in the exam, and in fact they have been asked on multiple occasions, especially the rainfall aspect of it. Even the optimum temperature is also very very important. So you should know that rice is basically a crop which requires minimum 10 degrees Celsius for germination. The ideal temperature is between 20 to 25 degrees Celsius, and the rainfall required is 1500 mm. Okay, so extremely high amount of water is required, and a relatively higher temperature is also required, 20 to 25 degrees Celsius. But if you talk about sorghum and pearl millet, they are basically grown in, especially pearl millet, it's grown in drier areas like Rajasthan, and over there the temperatures are also higher, and the requirement of rainfall is lower, right? Same goes for finger millet and kodo millet as well. Then wheat is basically a winter crop, so its temperature reduces as compared to rice, right? It's a rabi crop, and rice is a kharif crop. So again, because of rabi, its temperature becomes 16 to 22 degrees Celsius, and then the required rainfall, it's between 250 mm to 1800 mm. Then there is barley. Barley requires again much lesser rainfall, only 4 to 500 mm, and the temperature is, again, it's a rabi crop, so the temperature is 12 to 15 degrees Celsius for growth. And then there's oats and groundnut and so on. There are 27 crops. You need to remember the rainfall and the optimum temperature, most important. Altitude also, if you can remember, that's good, but these two are the extremely crucial ones which you have to remember. There's no other option. Okay, so I think we've come towards the end of our chapter, and thank you so much, guys. I hope you've understood all of the basic concepts which were there in this chapter. There's not a lot of questions which can be asked, a few tricky things which you need to understand, and I've tried to let you know about those things which can actually be asked. But apart from that, not many questions which have actually been asked in the last 2 to 3 years. So just go through the notes. I think you'll be able to understand things very well. So if you still have any other doubts, then you can of course email it to us on hi@litmode.in. But I think that would be a more kind of a tedious thing, and we would also not recommend you to do that. The first the first point of contact for any kinds of doubts that you have, I would always recommend should be the the comment section below, the comments of the discussion, because over there what happens is that if you have any doubt, and if it's already been asked before, then you can just refer to those comments, and it will be easier and time saving for you as well, because you also have to save your time for the examination. And then if it's not been asked before, then maybe your question can help others as well, so it's best to put it in the comment section below. And if you don't want to put it in the comments, then you can of course write an email to us at hi@lytmode.in, and we'll definitely try to answer your questions. So now for the next chapter, again I would recommend, before you begin with the third chapter's video, first go through the basic content of it. Then once you've had a gist of what's going on in the chapter, then you can start with the video, understand the details, the concepts, and then you can make your final notes out of the detailed notes. Okay, thank you so much guys. I hope you keep preparing well, and I hope you'll crack the Nabard exam this year.